Hi, good afternoon, everyone. So today's topic is about inductive and deductive. Okay. So you can follow this based on the slide in Google Classroom. I hope you have read about it. So this one. Right. Can you see my slide? Okay. Cool. Okay. So today we'll discuss about deductive and inductive reasoning. So any one of you have ever watched or read Sherlock Holmes? Or do you like detective story?
Me, sir. I have, sir.
You have. Okay. So usually, okay, Sherlock Holmes always said, "Oh, I'm doing deductive reasoning," okay, but in fact, what he is doing is actually inductive reasoning. Okay. So what is deductive reasoning and inductive reasoning? That's what we will discuss today. Okay. So, okay. Deductive reasoning. Okay, deductive reasoning is, or sometimes we call it deduction. Okay. Start out with a general statement. Okay. You have a general statement, and then you examine the possibility to reach a specific or logical conclusion. Okay. So from general to specific. So what is general usually? Usually general is a theory. Okay. You have some concept. Okay. And what is specific is the observation. Right? So in inductive, deductive inference, usually you hold a theory, and then now based on the theory, you make a prediction of its consequence. Okay. So what you predict? What you predict is the observation. Yeah. Of course, this prediction is based on assumption, okay, that the theory is correct. So anytime you go from general to specific, okay, from the theory to observation, okay, this is called deductive reasoning. Okay. So then what is deductive argument? Okay. Of course, deductive reasoning, yeah, will have the form, right? That form, the very common form, is called deductive argument. We have learned this many times. Okay, usually you have two statements, yeah, two or more statements. The first statement usually called major premise. The second is called minor premise. Okay, and then you have conclusion. Now, how do we know that this deductive reasoning is valid? Okay. So a valid deductive argument is one whose conclusion cannot be false while the premises are all true. Okay. So how do I know this is deductive? Okay. If it is valid, then the conclusion cannot be false while the premises are all true. Okay. Let's give example. Okay. So you have a premise one. No mortal can halt the passage of time. Premise two, you are mortal. Right? Then conclusion, you cannot halt the passage of time. So this is an example of deductive argument. Okay, what the premises are all true, right? Therefore, this is called sound deductive argument. Let's give another example here. First premise, if there is a nuclear war, then it will destroy civilization. Now, premise 2, there will be a nuclear war. So, thus, the civilization will be destroyed by a nuclear war. So, while premise 2 is not sure, right? But the conclusion could not be false if the premises were true. Thus, this is valid but unsound. Okay, so deductive argument can be valid and then divided into two, sound or unsound. Okay, how about this? Some pigs have wings. All wings thing sings. Then the conclusion is some pig sings. So what do you think? So this is clearly invalid. Why it is invalid? Because the premises are false, right? But this is still example of deductive argument. So up to here, is there any question? Can you distinguish valid or invalid argument? Yes. So in the next practices, okay, you will put this argument into premise and into premises and conclusion. So,
I want to ask,
cool.
what if the premise we don't know if it's true or false?
If the premise is not true, you don't know true or false, then you start to think about the probability. In that case, you will start to think in terms of inductive deduction, inductive inference later. Right? So if there is no probability, okay, it is either true or false, then it is called deductive. But you don't know true or false, right? So then you assign some kind of probability to it. Then it will become inductive. Okay. Good question. So is there any other question? Okay, so let's practice that. Okay, first, can you see this? My boss said the person with the highest sales will get a promotion at the end of the year. I generated the highest sales, so I'm looking forward to a promotion. So anyone can put this argument in the form of premise and conclusion.
Premise 1. Premise 1 is my boss said the person with the higher sales would get a promotion at the end of the years. Premise 2, I garnered the higher sales.
Okay.
Conclusion, I am looking forward to a promotion.
Oh, very good. Is it right?
Yes.
Yes. Okay, again. So who will answer this? Joyce.
Me.
Hmm?
Premise 1 is one of our customers is unhappy with his experience. And premise 2, he doesn't like how long it takes for a return phone call. And the conclusion is, if we provide a quicker response, he will be more satisfied.
Very good. Next, we will do this. Correct.
Premise 1, the career counseling center at my college is offering free resume reviews to students.
Hmm.
Premise 2, I am a student and I plan on having my resume reviewed.
Hmm.
The conclusion, I will not have to pay
Hmm.
anything for review.
Yeah, super easy, yeah. Next. Amara.
Premise 1,
Mhm.
I must have 20 credits to graduate this year.
Mhm.
Premise 2, I only have 18 credits. And conclusion, I will not be graduating this year.
Very good. Next. Who did not? Felicia. I think you're.
Oh, yes. The premise 1, our biggest sales come from executives who live in our company's home city.
Mhm.
Oh, wait, sir. I read it first.
Okay.
Oh, sir. Premise 1, our
Mhm.
biggest sales came from executives. The executive is lives in our company's home city. Premise 2. So the conclusion is we have decided to allocate more of our marketing dollars to targeting executives in that city.
Okay. Very good. So again, now yeah, what is inconsistent, right? So this is another term. Inconsistent, okay, is a set of statements that it is logically impossible for all of them to be true simultaneously. Okay, so inconsistent is also called logical conflict. Okay, so I'll give you a very simple example. All butterflies are insects. Some butterflies are not insects. So why this is inconsistent? Billy.
Because the fact that they provide is different, sir. So in the first one, all butterfly are insects,
Mhm.
and the second one is like the contrary. Like it's not how to say. It's provide the other way around of information from the first one.
Correct. Okay. So how about this one? Who did not talk a while ago? Who did not talk a while ago? Is Kenneth finish? Matthew finish?
No, sir.
Okay. So
This one is inconsistent because the first part, Jim is taller than Bob. Bob, the second premise, Bob is taller than Sally. So logically, Sally is the tallest one, but the third premises say that Sally is taller than Jim. Jim is the shortest one in the group
So this is inconsistent.
because it's not consistent, sir. It how do you say it? It broke the logic from the first part, sir.
So I will put it into variables. If A is larger than B, right? And then B is larger than C, right? Then you are hoping that A is larger than C. Right. So to be consistent, so you should say that A is larger than C. But how about if this is not taller, but actually preference?
What, sir?
Preference. For example, I like durian more than banana. Okay. And I like banana more than apple. Okay. So I like durian more than banana. And I like banana more than apple. If I say I like apple more than durian, am I inconsistent?
No, sir, because it's preference.
Why?
It's more like an opinion, sir.
So if opinion can be inconsistent,
Yes, I think.
so this properties is called transitive. Okay, transitive. So even in opinion, logically, we should always make it transitive. Even in preference, we should always make it transitive. Okay, but in human nature, we are not always transitive, especially if the transition here is very long. For example, A larger than B, larger than C, larger than D, and then larger than E, for example. Then you ask whether B is actually larger than E. You forget already. Right? So if you ask question, okay, very long question, people tend to forget. They don't even remember what they prefer. Okay, next question. Okay, I will remove this. So if A, okay, if A larger than B and B is larger than C, you conclude that A larger than C, isn't it? To be consistent, right? So now, can I put like this? I like apple. Okay, let's say apple, banana. What is the fruit in with C?
Cherry.
Hmm?
Cherry.
Cherry.
Okay, let's see. I like apple 2 times than banana. So A is equal 2 times of banana. Now I put number. I like banana 2 times than cherry. Okay, or 3 times. 3 times. I like banana 3 times than cherry. My question to you. How much I like apple more than cherry? To be consistent.
6, 6, 6.
6. So
Yeah.
say to be consistent, apple must be 6 times cherry, correct? So, but if I said I like apple 5 times more than cherry, is this still consistent? What is your opinion?
My opinion, I think it's yes, sir.
Why?
Because it's like I like something, so it based on our personal experience, right? So I think it's yes, sir.
So this one is still consistent. How about
Yeah,
if A is actually 7 times more than cherry?
I think it's still consistent
Still
because
consistent.
I like apple more than cherry. So whatever the number, I still like apple more than cherry.
Right. So why is it consistent? Because this is ordinal. So what we check is the order, not the actual number. Okay. What we check is what we call this ordinal number because preference is actually ordinal. You have order, but you don't really have that value of that number. The value of that number is not that important. Okay. Well, if you want to be exact, yes, you get 6. Okay. But how about if like this? Apple, I like apple just 3 times of cherry.
no, sir, it's not consistent. It's
More.
because 3 cherry is like the same with B, so it's unlogical. Well, he
Really?
A is B.
If A is 1, no, if C is 1, A become 3, right? If C is 1, A become 3. Now, how about P? Oh, the same as P. That's what you mean. Then it is illogical because they are the same. But the question is, sometimes strict or not strict is the problem, right? When we put like this in the preference, okay, and we put like this, yeah, meaning larger or larger than or equal, okay. So this is called strict. Okay? This is called not strict because equal is included. Yeah, in the order, sometimes we have strict order or not strict order. So in this case, if it is strict, yes, it is inconsistent. But if it is not strict, they are still okay. Okay, huh? Now I put consistent to numbers. Anyway, next time I will if you want, you can go to my tutorial. There is a tutorial called analytic hierarchy process. Okay. Discuss about this, and we can measure how much is the inconsistency. Okay. Using mathematics, yeah, using a linear algebra called eigenvalue and eigenvector, you can actually calculate that. Yeah. Okay. Anyway, that's beyond the class. That's why I did not discuss. Okay. How about this? This pole is either positively charged or negatively charged. It is not positively charged. It is not negatively charged. So
It's inconsistent.
inconsistent. Why, Kenneth?
Because in premise one, it's either positive or negative. However, on the second and the third premise, it is not positive or negative. So we don't know what it is.
When you said or, okay, when you said or, say A, oops. Okay, I will put blue now. A or B. So if A is true, so this is positive, right? And then this is negative, right? So how about if positive and negative? So what is the meaning of or in here? Either A, right? Or B. How about if both? Both A and B. Is that including in or not? Any opinion? I'll just make you confused.
Wait, sir, what do you mean with is it including in or not?
Okay, what's the difference between or and exclusive or? What is the difference between or? Oops. Where is my pen? Okay. What is the difference between or and exclusive or? What is the difference between or and exclusive or? Do you know?
I'm sorry, I don't know. Exclusive or.
Okay, okay. So say you have A and B, and then you have or of A, comma B. Okay. Now you have also SOR, exclusive or of A, comma B. Right? So A is either true, true, false, false. B is what? True, false, true, false. Right? So what is the truth table of OR? True, true become
True.
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 How about true, false?
True.
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 How about false, true?
True again.
True.
True again. How about false, false?
False.
False. Now, exclusive OR will say, if true, true, this is false. Because A and B, right? True, true mean A and B. So this one is true, this one is true, and this is false. That's the difference. What's the difference between OR and exclusive OR? If both are true or both are false, okay, then they are false. So in this case, this pole is either positively or negatively charged. And then you say this is inconsistent because it is not positively charged, it is not negatively charged. So what is this? This OR in here represent or actually exclusive OR.
exclusive or, sir.
Because not both, right?
Yeah.
You get it. You don't get it. So when I said this pole, okay, is both positive and negatively charged. It's not there. It's not included, right? Meaning the true is not there. So that's why this is inconsistent, because based on the understanding that or in here represent actually exclusive or. Because if or in here represent real or, okay, so this is actually still consistent. Why? Because the pole can be both positive and negatively charged. It is still true, you know. Is there any question about this? Do I confuse you or not? Can you give example of or, and can you give example of exclusive or? Anyone? Be careful when we said or, that one have two possibilities. The real or meaning can be both. Okay, A and B must be true also, right? So when we said or, A or B, that's mean what? Either A or B or both A and B. Right? That's meaning of or. When we said exclusive or, okay, it can be both. It can be either A or B, but not both. Okay, so in this example, the pole is either positively charged or negatively charged, but cannot be both. Right? Anyone can give example of XOR, XOR. You know, this exclusive OR is very important logic, you know. In the history of, for example, neural network, okay, in 1960s, they start to hype that, oh, neural network can solve everything. And then in 1970s, suddenly one professor from MIT stated that neural network cannot do SOR, cannot do XOR. Okay. And then suddenly everyone disregard neural network. Right? Until in 1980s, then they solved that problem. So there are big debate just because of this logic called exclusive OR. Okay. So first you start with the Boolean logic like this, yeah, and later on this is the basic for many others courses later that you learn. Okay, but when we talk about many other courses that you learn later, and you don't know what is XOR, for example, the SOR and OR, you don't know what is if then, wow, that will become very painful, right?
Sir, I wanna ask for this table. So AB are the premises?
And AP
Are the premises?
AP is not the premises. AP is
What
the
is a
A in here is positively charged. A is a positively charged. B is a negatively charged. It's not the premises. I'm talking about the first sentence.
oh the possibility? Yeah. Okay.
Okay.
So what is the or and X or?
No, I'm asking what is the meaning of or in this sentence? So in this sentence you have or, right? Yeah. So what is the meaning of this or? Is this or the real or this or is actually so? Right. And Matthew already said this is actually so, not the actual or. Right. Did you get it or you don't? Still.
I don't know. I don't get it.
You don't get it. Okay. So is there any pole that actually both positive and negative?
No,
No.
it's either positive or negative.
Exactly. So that means if both of them happening, so it's false, right? Right. So that means this or here does not mean real or, that this or here represent XOR actually. Okay. Now you get.
Okay.
Okay. So I'm just explaining what's the meaning of or here, because sometimes people are inconsistent. Or in here is the real or actually exclusive or that they are talking. Okay. Cannot be both. Okay. How about this? Today is both Wednesday and not Wednesday. And today I play golf. Why this is inconsistent?
Because if today is Wednesday, it cannot be not Wednesday. But if
Yeah.
today is not Wednesday, it cannot be Wednesday.
Yes. So because this is and. The keyword here is the problem. Okay, so I will put it into a if A and not A. So this is inconsistent. How about if I put it this way? If A or not A. So this is false, right? This is true. Okay. You want to try? Try to do a.
Try.
Okay, let's try. Okay, let's try to do a truth table of this. Okay, this symbol, okay, represent and. This symbol represent or. Okay, okay, let's try this A and not A. Can you make the truth table? Anyone who can show first can claim recitation point of that. One, you open your Excel. Okay. One is A and not A. The other one is A or not A. How many possibilities of A? What is the truth value of A? Either How many possibilities? It's one variable, so the possibility is only two, either true or false. Right? So, show the report. A and not A. Okay. So then what you will do? I will create a table of A. And then I will create a table of not A. So A is either true or false. Correct? So if A is true, what is not A?
False.
No. Okay, so if A is false, what is not A?
True.
True. Oh, so if A is true, not A is false, what is A and not A?
False.
This is false, right? How about this? If A is false and not A is true, what is A and not A?
False.
False. See? So both are false, right? Now let's do it this way. I want to do A or not A. Now, A is true, not A is false. What is A or not A?
True.
True, sir.
True, right? How about this one? A is false, not A is true. What is A or not A?
True too.
True too. See, this is tautology. And this is contradiction. Right? Correct. So by doing it into the truth table, you start to see. Okay. So next time when someone said, what is the earlier example? Today, yeah. Today is both Wednesday and not Wednesday. Right? So that is inconsistent, right? But when I said today is both Wednesday or not Wednesday, consistent or not?
Consistent.
Consistent, okay? Because or. Okay. So the problem is the keyword and here. Okay, any question until here? Okay. Now this is kind of big thing. So deduction from inconsistent. Okay. This is important. Any argument with inconsistent premises is deductive, regardless of what the conclusions say. Okay, this is what make it definition of deduction. Okay, an argument is deductive if it is impossible for its premises all to be true while its conclusion is false. Right? So then following this, okay, thus since it is impossible and under any condition for inconsistent premises to be all true, right? Then it is also impossible that these premises to be true while some of the conclusion is false. Right? So the premises cannot be true. So hence, any conclusion follow from deductively from inconsistent premises. So if you create, okay, deductive, if you create premises which are inconsistent, regardless your conclusion, it is always deductive. So if asking, is this deductive or inductive? Okay, then you check if the premises are actually inconsistent, okay, they are deductive. Okay. So deductive does not mean valid. Okay. So this is an example. This book has more than 900 pages. This book has fewer than 800 pages. Therefore, this is a very profound book. So this is deductive, right? Why? Because impossible for the book to have more than 900 pages and fewer than 800 pages. Right? So because the premises are inconsistent, okay, while the conclusion is false, therefore the argument is deductive. Okay? So actually the premises and the conclusion are irrelevant in this case. Any question? Okay, so I put note here. Okay. Note that although any argument with inconsistent premises is deductive, okay, no such argument is sound, since inconsistent premise cannot be all true, right? So no conclusion can ever be proved by deducing it from inconsistent premises. Okay, so yes, it is deductive, but it doesn't mean it is sound. It doesn't mean it is valid either. Okay.
But can deductive be valid?
From inconsistent?
If can it be consistent, deductive? I don't know what is deductive.
Your question is, if I have a premises that is actually true, okay, all true, and they are consistent, okay, then can the conclusion be valid? Yes, of course, right? We already talked that in the earlier, actually, right? Here, these are the example of deductive that is sound, okay? Correct? So this is also example of valid but unsound. Why unsound? Because P2 in here is
What example?
no?
What example?
This is the example here.
It's the white book.
Oh, story, why still what for? This is the example. And this is the example earlier. I hope you remember in the beginning. So these are the example of valid, sound. This is valid and unsound, right? So, and this is invalid. Okay, so where am I? Okay, here. All right. So next is another topic already. So deductive argument, deductive inference. Is there any question? So tell me what is deductive in this case? What do you mean by deductive? Deductive means from general to specific. Okay. Deductive also means that if all the premises are true, then the conclusion should also be true. Right? And the last one we said, if the premises are inconsistent, regardless the conclusion, it's also deductive. Okay? Okay, so let's discuss inductive, and then later you will start to see the difference. Okay, between deductive and inductive. Okay, where is the sharing of the screen? Okay, it's the other way around. Inductive reasoning. Inductive reasoning, okay, make broad generalization from the specific observation. You start from the observation, from the data. Okay, and then you generalize it. Okay, you create a hypothesis, you create a theory. Okay, or some certain conclusion based on that. Right? So again, it's the other way around. Okay, in deductive, you start with the theory, the explanation, right? And then you talk about the observation, something that you observe. Inductive is the other way around. So you start with your observation. So you make observation data, and then you discern some pattern. Okay, so you get certain pattern based on the data, then you generalize. Okay, how do you generalize? You create a concept, you create a theory. Okay, you create hypothesis from the fact. Okay, actually, you did this a lot of times. So this is an example. Dog A and B have fleas. This is your observation. Then you start to see certain pattern. What is the pattern? Oh, I saw that a lot of dogs, okay, all the observed dogs have fleas. Then your conclusion is, this is actually still a hypothesis, right? Is that all dogs have fleas. So can you see that this is generalization? Okay, you start with the observation, right? And then you get certain pattern from the observation, right? After that, what you will do? You create a hypothesis. Okay, so I don't like to put this as conclusion because this is actually still generalization is based on not real conclusion yet, still hypothesis. Okay. But creating this kind of hypothesis is important because science can progress using both deductive and inductive. You cannot have only deductive. You cannot also have only inductive. It should be both. Okay. Again, how about this? You observe that elephant depends on water to exist. Okay. Based on your observation, then you start to see certain pattern. What is the pattern here? That all observed animals depends on water to exist. Then you create a hypothesis, okay, or conclusion here that all biological life depends on water to exist. Right? So you see, start from elephant, which is specific. and then you generalize into all animals, and then you generalize again into all biological life. Why I say this is hypothesis? Because there probably certain biological life in other planet which does not really depends on water, right? Any comments? Any questions? Can you give an example, other examples? Oh,
So I want to ask.
go.
So inductive is the valid and invalid inductive.
There is no valid and invalid inductive.
Okay.
Okay. In inductive, later you will see. Is we can just call it weak and strong, because in deductive you can say valid and invalid. Okay. When it is valid, you can say it is sound or unsound. But in deductive, we cannot say that. We cannot say it is valid or invalid, because you generalize, you see. There are certain probability there, isn't it? Right? So in that case, we can only say this is weak or strong. The term is not valid or invalid. Thank you. Any other comments? Question? So if not, can you give me example of inductive? So what is your observation? What is your pattern? And what is your hypothesis? Come on. Who will start? Every one of you will create an example. Right. So, who is ready first?
Me,
Yeah, go.
drawing paper and textbook paper are terrible.
Observation is?
The observation is drawing paper and textbook paper are terrible.
Drawing paper.
Drawing paper and textbook paper are terrible.
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 And then your pattern is?
All paper are terrible. The hypothesis.
Terrible. Okay. Can be terrible.
Yes.
Okay. So your hypothesis is?
All paper are terrible.
All paper are terrible. Okay. Any other example? So Kenneth is finished. Anthony.
Wait, sir, wait.
Wait. Okay. So who is ready first? Tamara.
She becomes successful after graduating from MIT.
C. Okay.
And then observe students from MIT become successful after graduating.
Okay.
And then my hypothesis, all MIT students will be successful after graduating.
Okay. So that is the hypothesis, because not all actually, right? Okay. But very good. Good example. Okay. Who else? Billy, you're smiling.
Yeah, me. Ants in my house bite. So, and the pattern, all observed ants bite.
Okay.
So what is the third one, sir?
Hypothesis.
hypothesis, all ants bite.
All ants bite. Okay. So you start with specific with this in your house, right? And then you create the pattern, probably all ants in your house bite. Okay? And then you generalize it, all ants bite. Okay. Which is not necessarily true, but you conclude it based on that. So this is kind of generalization. Okay. Very good. So who else? Choice.
Me.
Mm-hmm.
I like chocolate.
You
Yes.
don't like chocolate. Okay, that's
I
what.
like.
Oh, you like chocolate. Observation.
Yeah. And the second one, what's the second one?
Pattern.
And parent, all my girls friend, they like chocolate.
Okay, all your friends, they like chocolate. Okay, and then the hypothesis.
Hypothesis, all girls like chocolate.
Like chocolate. Okay. Even though it's not always true, but that is generalization. Very good example. So who else? Three more, right? Alicia, Matthew, and Anthony.
These are me.
Oh,
Oh, observation. On 17, I make ID card.
okay.
And then the pattern, my best friend makes an ID card when she's
Turned
17.
17. Okay.
And hypothesis, all of civilians who are already 17 make an ID card.
Yeah, in Indonesia. Okay, that's good. Yeah, good example. So in other countries, they don't have ID card. Matthew. Anthony after that, huh?
I eat food to survive, and that's the observation. And other people eat food to survive also. The
All
pattern,
animal.
all observed people depends on food to survive, and the hypothesis, all people depends on food to survive.
Very good. Anthony, easy, right?
Easy.
Yeah, after
my,
medical.
my observation is the girl in IBE is beautiful.
Okay.
Pattern, my friend in IBE is beautiful.
Okay.
Hypothesis, all girls in IBE are beautiful.
Oh, what is the pattern again?
My friend in IBE is beautiful.
Okay. Or female friend, you mean?
Yeah.
Okay. Okay, good. So you start with certain observation, and then you get certain pattern from the observation, and then you generalize it. Yeah? So the way you generalize, you see, you can generalize in terms of space, in terms of time, in terms of many other features, right? Okay, excellent. So I think you got what is the meaning of inductive, right? Easy. Okay. So here is other examples. Where am I? Oh, here. So a low-cost airline flight is delayed. Okay. And then another 20 flights from low-cost airline are delayed. That is the pattern already because not just one, right? And then now your hypothesis, low-cost airline always have delay. So this is the common, if you live in Jakarta, I'm not sure if you live in Surabaya, you can have this problem. So if I go home by this time, say between 5 to 7, I usually caught in traffic congestion. Okay, that is the observation. The pattern, I did that for several times based on the time, and most of the time I was caught in traffic congestion. So the hypothesis, if I go from 5 to 7 from the office, if I go home, then I will be caught in traffic congestion. Right, the same thing. Here, after I ate strawberry, my lips swell. That's observation. Okay, so there is information here. So the swollen lips after eating strawberry may be a sign of an allergy. So the information here represent the pattern. Okay, so the hypothesis is likely I am allergic to strawberry. How about this?
I want to ask,
Cool.
for this statement, can the likely be removed?
Yes, you can say you just say hypothesis I'm allergic to strawberry.
Okay, thank you.
Problem if you put that, okay, then it become deductive. It's no longer inductive. Right? If you put the likely in here, remove and put off the likely in here, then it's become deductive already. Correct? What's the difference between inductive and deductive is, in inductive, there is certain probability. Yeah. In deductive, the probability is 1. Sure. Right. So that's the difference between deductive and inductive. So very good, Kenneth. So if I remove this likely, the keyword here, likely, what will happen? It becomes deductive. Right. So the observation become the premise 1, the information become premise 2. Right. So what make it inductive here is the probability that this conclusion is true. Okay, so another example. I saw a swan and it is a white swan. Pattern. I have seen 100 swan and all of them are white. Hypothesis. All swan are white. Okay. I keep repeating the word hypothesis here instead of conclusion. If you read other book, they will tell this and this is a conclusion. But the word conclusion should not be used because this is actually still hypothesis. Okay? Because you can see that there is possibility, okay, to find a black swan. And be careful with inductive. Okay, look at this example. If I wore my sock inside out, I perform very well in my exams. Right? Then it creates a pattern. I did that several times, and most of the time I perform very well in my exam. So if I wear my sock inside out, I will perform very well in my exam. So it's become superstitious belief. Is there any of you have superstitious belief? So I give example, another one, which is not here. Say, someone invite you, okay, to my house, and I give you a wine. Okay, I give you wine and a water. I put water in the wine, and then you drink, right? And then you get drunk. Next time you come again, I give you beer, and then I mix with the water. And then after you drink sometimes you get drunk again. Okay? And then next time you come again, I give you, tua, okay? The local liquor, right? And then I mix with water, and then you drink again, and then again you get drunk. So the conclusion is, the hypothesis in this case, water make you drunk. Is that correct? Because in
But that this makes me drunk.
yeah, because in all three cases, okay, there's water there, right?
But in all three cases, you are there, not everywhere else.
Okay, so I'm also there. That means my presence make you drunk. Right? So my point is be careful with the generalization. Right. So let's make the distinguish between deductive and inductive. Okay. Where is the where's the deductive and inductive? Here. So again, yeah, deductive is useful to apply theories to specific situation, right? While inductive is useful to form hypotheses to be tested. So both are useful. In fact, if you see the development of science, we need both inductive and deductive. Okay, so deductive aim at testing an existing theory, okay, while inductive aims at developing a hypothesis. Okay? So deductive should be from general to specific, while inductive from specific to general. Okay, let's start to see, okay, what is inductive argument. Okay, so in inductive argument, okay, which is one of those conclusions is not necessarily relative to the premises. Okay, there is a certain probability that the conclusion is true if the premises are, but there is also probability that it is false. Right? So because of its probabilistic nature, we cannot say the inductive argument is valid or invalid. We can only say it is strong or weak. Yeah, inductive argument based on its probability. So how do you say it is strong if the probability is high? Weak if the probability is low. Clear, yeah? So how high? Yeah, high, I will say 0.8 and above, right? And how low? So less than 0.2.
Sir, you're still muted, sir.
What happens if the probability is between 0.2 to 0.8?
It's not strong nor weak.
Yeah, it's not strong
It's
or weak.
mediocre.
Yeah, we don't know. I think something is wrong. I don't know why I keep.
Yes, I don't know.
It happened in physics too. So
I don't know why it go out by itself and then come back again. This is so strange. Maybe the internet connection.
No, I think there is a problem with the Zoom, sir.
With the Zoom.
Yeah, it happens from this morning.
Oh, really? Oh, Zoom itself.
Maybe
Yes, Zoom itself.
there is a probability.
That's
Yeah, there is a probability.
So you start to apply the logic. Very good. Okay.
Inductive argument cannot.
Right. Okay. So let's practice, okay? So the question is this. Of the two inductive arguments below, which has the higher inductive probability, A or B? In A, visitor to China almost never contact malaria there. Chan is visiting China. Thus, Chan will not contract malaria there. B, slightly fewer than half the visitor to China contract minor digestive disorder there. Second premise, Chan is visiting China. Thus, Chan will not contract a minor digestive disorder there. So
A is higher
A is higher. Why?
because almost never.
Okay, so the keyword there, okay? The keyword there is important, okay? So in here is slightly fewer than half. The other one is almost never. Okay, so almost never in the first premise led to greater probability. Okay, so okay, how about this? Is this argument weak or strong inductive argument? Okay. I dream about monster. My brother dreams about monster. Thus, everyone dreams about monster.
We
Why?
because the what is called, it's only I and my brother. However, everyone is too many billion. Therefore, 2 divided by billion is low.
Right. So very small sample. Okay. So Kenneth is very good. He read already. That is excellent. Okay. So why it is inductive? Because you generalize, right? You see, start with I. The second premise is my brother is only 2%. And then after that, the conclusion is, okay, in this case, generalization, right? It's become hypothesis that everyone dreams about monster. So everything that generalization is actually inductive. Okay. Is it clear? Inductive, deductive. Okay. How do you distinguish? Is there any probability? Right? If it is just probability, then you start to see, oh, it is inductive. Okay. If the probability is 1, it is deductive. Okay. Yeah. How about this? Is this argument weak or strong?
Strong.
Why?
Because 90%.
Because 90%. Okay, right? So probably in the exam I will ask, is this inductive or deductive? So it's clearly inductive, right? How about, yeah, this is the, you just read this, okay? So 90%. How about this? This is a little bit difficult. Chemically, potassium chloride is very similar to ordinary table salt, which is sodium chloride. Thus, potassium chloride tastes like table salt. Is it true? Okay, so this is inductive generalization. Okay, where the chemical are the same, the taste is not necessarily relative to the chemical compound. Yeah? It's not necessarily the potassium chloride is salty. They're irrelevant. Okay. How about this? It is usually cloudy when it rains. And then P2, it is raining now. The conclusion, it is cloudy now. So what is, so the word usually there is the most important. Okay. So you can see that there is a certain probability that the conclusion is true if the premises are. Okay, but there is also probability that it is false, right? Any question? It's clear, yeah, because there is usually there. Oh, I removed the word usually, right? So it is, if it is snowing, it is cold. It is snowing. Then the conclusion is it is cold, right? So this is example of deductive inference. Why? There's no probability here. Okay. Now let's change that a little bit. It is, when it is snowing, it's usually cold. Okay. P2, it is snowing. Conclusion, it is cold. Now, almost the same, right? The only difference is only the word usually, right? So now become inductive. It's no longer deductive. Can you see the difference? Okay. So the conclusion here is valid only with certain probability. That's why this is inductive. So can you distinguish deductive and inductive? So, okay, this is like the summary, okay? So if you have an argument, it can be deductive or inductive. Yeah? How do you say? Deductive, the conclusion is necessary follow from the premises. Okay? While in inductive, the conclusion follow the premises with certain probability only. Then you check to determine the validity or the strength. So if we assume that the premises are true, does the conclusion follows? Okay. Then we can say that deductive can have either valid or invalid. Okay. Then from there, okay, we can also say if it is valid, then we can divide again into two. Okay. Sound or unsound. Sound mean what? Sound mean valid, the form is valid, and all the premises are true. Okay. Unsound, what is the meaning of unsound? The unsound means it is valid in terms of the sound, in terms of the form, but not all the premises are true. Okay. Of course, when it is invalid, it's always unsound. Okay. Now, inductive, okay, depending on the probability, you can say it is strong or weak, yeah, not valid or invalid. Okay, then we can also say if it is strong, we can divide into two, okay? Cogen or uncogen. Okay. Cogen mean strong and all the premises are true. Okay. Uncogen mean what? The probability is strong, but not all the premises are true. Okay. How about weak? The probability is weak, then it is uncogen, always. Clear, yeah? With this.
So why is the weak cannot be cogen?
Oh, cogen means strong and all the premises are true. But
But if it's weak and all the
premises
statements are
are
true,
true,
yes,
but it's weak. So the weak mean you are not sure already, right?
weak means unsure.
Yes, the probability is very low that is happening. So that means you are not sure, right?
Okay.
But for the strong and uncogen, what is the meaning of that, sir?
Strong uncogen mean you have high probability, but not all the premises are true. Okay, not all the premises are true. Remember the word "and" here. In logic, we dealing with the word "and," or, if, so, if and only if. Yeah. Later we will discuss about if and only if. Maybe after the midterm. Hey, tell me first, when is your midterm?
Next week,
Next week, what day, and what time?
logic.
Logic.
It's on Thursday.
Yes.
Thursday is
7.
what? 7. What time?
Yes,
9
7.
to 11.
9 to 11.
9 to 11. Okay, I will take note. Okay, so the exam is multiple choice inside Moodle. Okay. Moodle, inside the Google Classroom. Sorry. You're using Google Classroom, right? So in the
The
What
material?
is the material?
until today, from beginning until today.
Oh, all multiple choice.
All multiple choice, but be careful with this. So you need to answer all the possible correct answer. For example, you have A, B, C, D, E, okay? And the possible correct answer is 3 of the 5, right? If you only check 1, then you make mistake. You get 0 on that question. So you need to.
So all 3 have to be correct.
Yes. So if you check wrong, it's also 0. But if you check not complete, it's also 0.
Why 0? Not some number.
I hope if we use Moodle, we can do a partial answer, but Google Classroom does not allow that. So that's my problem with that. Google Classroom. Very unfortunate. So you just be careful. Anyway, it's very easy. Just you just need to read all the slide, right? And you need to know where it is.
How many numbers?
How many questions you mean?
Yes.
I did not make it yet. So How many questions do you want?
Enough to make not my brain hurt.
What that mean?
The fewer, the better, sir.
Oh, fewer the better. Okay, I will make 2. No, probably 10. Okay. So just 10 questions. I think you can finish in maybe 5 minutes. Right? It's multiple choice, so you just check, finish, and then submit, finish. My exam is always easy. Yeah. I will not give any question outside the material that I gave you. So you don't need to worry. Okay, but you need to read. That's it. Okay, everything is in the slide. That's my point. So this is based on the philosophy of education, right? So if we test you with different materials, that is very unfair to you. Right? So I just do exactly the same things that I teach you. But you just need to know where. Because when you work later, okay, or if you use some of this material for your work, what you will do is you will also check back, right? Where is it? Okay. That's it, right? So, okay. Let's continue a little bit. Sound argument. Do I share my screen? Am I still sharing my screen? Yes. Okay. Sound argument. So an argument, a deductive argument, okay, all of those basic premises are true is called sound. Okay? So, so an argument established with certainty that the conclusion is true. So, of course, this is the best argument. You need to make it sound. Okay, sound is not just valid. All the premises are true. Okay, so this is example. Everyone has one and only one biological father. Full brothers, not step brothers, full brothers have the same biological father. No one is his own biological father. Thus, there is no one whose biological father is also his full brother. Correct? Sure, right? So this is sound argument. How about this? Oh, this is interesting. Is this argument valid or not? Tommy reads the Wall Street Journal. Thus, Tommy is over 3 months old. You know Wall Street Journal, right? The newspaper. Okay.
Oh, me, I don't know.
Okay, I'm telling you. So the Wall Street Journal is the newspaper. Okay. So Tommy reads the Wall Street Journal. Thus, Tommy is over 3 months old. Is this argument valid or not? That's the question.
Oh, because you can read it without understanding it. You can just see it and it read.
Yeah, logically, it's possible that 3 months old can read. Okay. Practically not possible. So it is logically possible for the conclusion to be false, right? While the premises is true. Okay. The conclusion, Tommy is over 3 months old. Is it possible that this conclusion is false? Right. Because 3 months old you can read? No, right? So the argument is invalid. Yeah. Why is it invalid? My question to you.
Because the conclusion is wrong.
Yes. If the conclusion is not sure, okay, can be false. So that is invalid. Now, okay, practice now. Classify the following argument is either deductive or inductive. No mortal can halt the passage of time. You are mortal, thus you cannot halt the passage of time.
Deductive.
Hmm?
Deductive.
Deductive, okay. How about this? It is usually cloudy when it rains. It is raining now, thus it is cloudy now.
Inductive.
Why it is inductive?
Because usually it
Usually, okay,
has probability to not.
correct. How about this? There are no reliably documented instance of human being over 10 feet tall. Therefore, there has never been a human being over 10 feet tall.
Inductive.
Why?
Because not 100% sure.
Because not 100% sure. Yeah. How about this? Some pigs have wings. Thus, all wings things sing. Some pigs sing. Inductive or deductive?
Deductive but unsound.
Hmm. In fact, it's not just unsound, it is invalid. Why this is invalid?
The premise is not true.
The premise is not true. Okay. So this is deductive. How about this? Deductive or inductive?
Deductive.
Deductive. Okay. So how about this? Deductive or inductive?
Inductive.
Inductive. Okay. Why is it inductive?
Because probability is not 100%.
It's not the, there is no probability here. It's the relevance. There is no relevance between the chemical compound and the taste. Right? It's about the relevance between the premise and the conclusion. Ah, this is like a while ago, but so is this deductive or inductive? R. This is
Deductive.
Deductive.
R. Deductive, okay? How about this?
Inductive.
Relative, right? So anyway, this is the answer, okay? A while ago. You can check. So inductive argument, yeah, is either strong or weak, yeah, not right or wrong. So not valid or invalid, okay? The conclusion is not always true, when the premises are true. Okay, so everyday inductive reasoning is not always correct, but it is often useful. Okay, while deductive argument, okay, we decide whether a deductive statement is true by assessing the strength of the link between the premise and the conclusion. Okay, in deductive reasoning, when the form is correct and the premises are all true, then the conclusion is guaranteed, okay, to be always true. So this is why later on after midterm, okay, majority of what we discuss are deductive argument. Okay. So this is another topic, but this is also important. Okay. So deductive argument remain deductive if a new premise are added. Okay, regardless the nature of that premise. But in inductive argument, by contrast, it can be either strengthened or weakened by the addition of new premises. Okay. The probability of a conclusion inductively from the two premises may be radically altered by the acquisition of the new evidence. Okay, let's take example here. First, very few Russians speak English well. True, right? Sergey is Russian. Thus, Sergey does not speak English well. So, this argument is strongly inductive, okay? It has high inductive probability, right? So the premises is also quite relevant to the conclusion. So this is strong inductive. So what happens if we add, okay? We add these premises. Very few Russians speak English well, and Sergey is Russian, and then we add this too. Okay. Sergey is an exchange student at an American university. An exchange student at American university almost always speak English well. Thus, Sergey does not speak English well. What do you think about this? So, when we add these two, okay, quite relevant premises, right? But now, the inductive probability become very low. Right? Sergey is Russian. Yes, very few Russians speak English well, and Sergey is Russian, that's okay. But Sergey is an exchange student at American University. Of course, American university student must speak English well, isn't it? But the conclusion said Sergey does not speak English well. So suddenly become weak inductive, isn't it? Adding premises in the inductive argument will change from low to high or high to low. It is possible to do to be like that. Okay. And now we add again. What is we have? So suddenly we say Sergey is a deaf mute. That's why Sergey does not speak English well. What happened if like this? So suddenly, okay, this is no longer deductive, no longer inductive, okay? So this is now become deductive. Can you see that or not? So inductive probability is now become 100%. So you can see here, these are the example. Okay, from inductive, and then you add more premises, okay, and then it becomes deductive. Okay, so now your practice. Can you add a premise, one premise only, okay, to the following inductive argument so as to make it deductive? I haven't bought any food. You haven't bought any food. Thus, there won't be anything to eat tonight. Why this is Why this is inductive first?
There might be food at home.
Yeah, because why this is inductive? That is the question first before adding argument. Before adding premise, why this is inductive?
Yes, because there might be food at home. Because there might be food at home.
That is the premise that you want to add, right?
No, because if I and you are in home, there might be food at home. So there might be food to eat tonight.
Okay. So then the conclusion is not sure. Is that what you argue? But you see here,
It has probability.
It has probability. Okay. So that's correct. So the argument is inductive because it is conceivable that someone else have bought food or there was already food in the house, right? So when you want to make it deductive, what you will do, you add this premise, example. There won't be anything to eat tonight unless one of us bought some food. So again, there is some implicit assumption here. So until here, is there any question? So what did you learn today?
The difference between deductive and inductive.
How do you distinguish deductive and inductive?
With the probability of the conclusion and the theory about the inductive is we make a theory like from specific to generalization.
From specific to generalization, that inductive.
Yeah, and deductive is the other way around.
Okay, and then what else? What else did you learn?
How to make inductive
How to make
deductive.
Yeah, from inductive you can make it into deductive, right? By adding
sentences.
By adding premises, right? Okay. Okay, hopefully this is useful. So I want to discuss with you about the debate. Yeah, we still have 10 minutes, right? So I want to discuss with you about the debate. So you can suggest to me, you can email me what topic you want to put as debate. Okay, and then we'll vote in the class after the midterm. Okay, we will cast vote on the topic that you suggest, and then once we decide which topic, okay, then you have a time to prepare the debate. So you will have 2 times debate. Okay. Group debate.
So sir, it's only one topic for everyone.
To make it win or loss, that means the topic must be the same, isn't it? Right. Or at least, how many are you? How many groups? Three groups. Oh, so
Yeah.
three group is odd number. So I guess we need to make it. So in that case, I will name group A, B, and C, right? Then you will do A and B, A and C, and then B and C. Right, because three. If even number, then only two pretty much. Okay, so anyway, the first meeting after the midterm, we will cast vote. Right. So during this midterm, you give me topic. Okay, you can suggest any topic that you want. Of course, the topic must be controversial. Otherwise, it's not so useful to make a debate, right? So now, after that, okay, you need to make both argument. Yeah? Either you are pro or you are cons. Okay, we will throw a random number. Okay, you must be ready for both sides. Okay, so we will, for example, group A contra with group B. So then which one will be pro, which one will be cons? Huh? So, and then again, the other way around. So after the midterm, it's more fun to do a lot of debate. Okay. So at least 6 times, right? So 3 in the beginning and then one more time. So the second debate between the same pair of groups, that means you can, because this is recorded, then you can start to make an argument. Okay. The first debate is just an argument based. You give a statement. Right? But the second debate, say 1 week after, okay, that part is your defense. Okay, prepare. So I hope this make it fun. Okay, and I practically give you all the materials already in the Google Classroom, right? So you can start to read also, because there are certain material that is so the reference you can start to read, okay, and then what? After the midterm, we will discuss about proposition, criteria development, Boolean algebra, it is mathematics, and then we discuss about proportional logic and proportional calculus, okay, and then the last part is the predicate logic and syllogism. So you can start to read, and from there, if we can finish early, I can add more materials. I'm planning to add, for example, about probability, about algorithm, about fuzzy logic. But I don't know if we have time or not, so I did not put yet. But if we can finish earlier, then and we still have time until the end of the semester, then we can. Okay. Good. So thank you for today. Matthew, you want to share your QR code, or you do manually?
I'll do manually, sir.
Okay.
Sir, I have some question. Is it still okay, sir?
Oh, of course.
About the last PPT at the last slide, where there's a statement, and it's an inductive statement. And how do we make it the deductive statement?
Mm-hmm.
On the PPT, it was added when there will be no food unless we bought some food, right, sir?
Wait.
That's one of us bought food.
Food. The last one was evaluating argument.
The food part, sir. The one that we bought some food.
We bought some food. Which page? What page number?
Last, just at the last, sir.
The last one is the sheep. Some sheep are black, some sheep are white. Is that the one?
Oh no, the food. I forgot what page number.
Is this the last one was this one?
Oh no, sir. I think it's around 50 something, sir. Page.
Page 50 something. But last me.
The one that we just studied, sir, about food, right, Matt?
Yes.
What number? What is the number of the slide?
I don't know, sir, because at Google Classroom, the PPT only until 30 something, sir. 30 pages.
30. So you are in predicate logic already?
Wait.
I'm not sure. Can you share your screen so that I will know what you're talking about?
Okay, wait, sir. Am I visible, sir?
Okay, so which one?
This part, the inductive versus
deductive. Today, this is today's lesson.
Yeah, but the question that I want to ask is not in this PPT, sir. I already found it, but there's none, sir.
What is your question then?
My question is, when we last studied, there's a question where about food, when Kenneth said that statement is inductive because there could be food at home.
That one.
Yes, but
there is here.
Oh wait, let me stop sharing.
Okay, the food. Is this the one? Page 62, you mean?
I'm not sure, sir. What page?
Is this the one?
Yes, that's the one. I wanted to ask about that.
Okay, what did you?
At the point 2, it becomes deductive if we add the premise, right? I wanted to why when we add that premise, it becomes deductive, sir.
Because when we add this premise, suddenly this is no longer probability, right?
But there's probability still, sir. There could be food at home without us buying the food. Isn't it, sir? Or maybe the food from last day.
But if you look at the context here, okay, I haven't bought any food. You haven't bought any food. And then I will say, there won't be anything to eat tonight unless one of us bought some food. That means there is an implicit assumption here that there is no food already in the house. Correct?
Oh, yes. Oh, so there's an assumption, yes, sir.
Yes, look at this. There won't be anything to eat tonight.
Oh, I see now, sir. Yes, sir.
Yeah, can you see that? So there's an assumption there that this possibility that there is already food in the house is not there anymore, right? Because he is saying there won't be anything to eat tonight, correct?
Oh, yeah. Okay, sir. Thank you,
Right.
sir.
I understand because you said it's or, right? It should be either this one or that one. But why suddenly there is no possibility that there is food in the house? Because he is saying that there won't be anything to eat tonight. That means there is assumption there, right? Even though that's not clear, but there is an implicit assumption, correct?
Yes, sir.
Hmm.
Sir, I wanted to ask,
Okay.
where do you found this PPT, sir?
Where do you find this PPT? It's not there?
The one in Google Classroom, it's only until page 30, sir.
Ah, really?
Oh, yes.
In Google Classroom is only page 30?
Yes, I think.
Yes, sir.
Okay.
Yes, it's your key.
Okay, I will update them. Sorry. In Google Classroom is only page 30? Oh, I don't know that. Oh my goodness. I did not update. Okay, I will update them.
Okay, thank you, sir.
So I will update today. Save as. Is this the only slide that missing or the others also?
I think there's a lot, sir, that I cannot find. Or maybe I could miss something.
So if you find some missing slide, okay, you text me, I can update it.
Okay, sir.
No problem. Okay. Sorry for that. Okay, so see you after the midterm. Okay, bye-bye.
Okay, see you, sir. Thank you.
Thank you.
Okay, thank you,
Thank you,
sir.
sir.
Thank you.